But no one is.
We are live now, so whenever you're ready.
So welcome to Cranfield University. I'm Andrew Starr, and I'm going to introduce you to the team from the Centre for Life Cycle Engineering and Management. We're going to show you a vehicle which is here at our Cranfield, here at the Railway Innovation and Test area at Cranfield University, and we're going to show you a vehicle which we've built in collaboration with Network Rail, indeed one of a series of demonstrators. I'd like to remind the audience to post their questions in the chat, please. And now I'm going to hand over to Mazume, who will introduce the demonstration.
Okay, sorry.
Mute the speakers.
Hi everyone. The purpose of today's test is to demonstrate the usability of this robotic system for railway tracking inspection and repair tasks. The main component of this robot is Warthog from ClearPath company. This robot has a number of sensors such as RTK GPS, 3D LiDAR, RGB camera, and an IMU and a wheel odometer that they are embedded in the body of the system. This Warthog runs on the ground, but because of the size and the type of the wheels, it cannot move on the railway track. So in order to transform this Warthog into a rail vehicle, we have designed and fabricated a trolley. After shifting the vehicle on the trolley, by the movement of the wheels of the vehicle, the wheels of the trolley will start moving and the whole set will move on the railway track. Today, we are not going to demonstrate to detect actually the real railway defect. Instead, we have a dummy defect. And in order to show the capability of this robot to detect different kinds of defect, we are going to have different kinds of QR code. Each of these QR codes have unique messages, and based on these messages, the arm would have different poses and will actuate different poses and capture different images from different angles. In terms of the inspection test, when the vehicle is in the initial location, when it receives the command, the arm will go to the straight pose and then goes to the inspection pose. In a way that the camera can capture the railway track, and then it would start moving. When the camera captures the defect, finds the defect, the vehicle would stop, and again the arm would start moving and actuating different poses and capturing different images for further processing. Now my colleague Fayang will show the demonstration.
So hello, this is Fei Yang. Now the robot is standby. This is the initial position of the camera. So in the real scenario, the camera will be replaced by the ultrasonics inspection kit or any other maintenance equipment. The robot is approaching to the QR code now. The camera detected the QR code, so the robot stopped. The camera is capturing the images of the QR code from different directions. Now the demo finished. Over to Adi. Adi will introduce more details about the robot.
Yes, this is Ade, a researcher from Cranfield University. So what we have here is the Warthog. It's got a lot of sensors on board, and we have the GPS and for localization and mapping. We also have the camera, which views around, which can be used for demonstration to pick up signals from obstructions along the road track. We have the LiDAR, which is a beam of laser that transmits data and then pick up signals from obstacles, which can be used for obstacle avoidance. And all this integration comes with the ROS component. The ROS component is the robot operating system, which is the algorithm designed and developed to integrate all the I/O systems, the input and output, which are the sensors and the actuators. So all the sensors will pick signals and then send all the commands into the ROS component. And the AI algorithm developed for autonomous navigation control are also embedded into the system. And I'll hand over now to Jian, which will explain in detail.
Videos. Yeah.
To Jian, that will explain in details how the obstacle avoidance works. Thank you.
Hello everyone, at Robot Life. I'm Jian Li. I work on the software development for this robot. This is our latest railway robots and automated bench trolley. It has similar feature as the Warthog robot we talked before. The main difference is it's railway ready. It has the wheels ready to go on the railway track without any conversion. Today I'm going to show you an example of collision avoidance with the LiDAR sensor. Our LiDAR works by sending beams 360 degrees to the surrounding environment up to 200 meters, so it can have a clear view of what's around you. Today's demo, the robot will travel to the end by detecting this obstacle, which is the fake policeman, and eventually slow down. It will continue moving when the obstacle is cleared until reach the end. Now the robot starts moving. Now the robot detects the obstacle and stop. The robot will stop unless the track is cleared. Now we clear the obstacle. The robot continue moving.
Hi everyone, my name is Masum Rahimi. I'm a PhD student at Cranfield University. My research was about developing and implementing autonomous localization and navigation for the robot inspection and repair system. This robot also equipped with a number of sensors, RGB camera, 3D LiDAR, RTK GPS, and IMU and a wheel odometer. This vehicle has been considered to perform on and around the railway track. But considering the railway environment, that is too complicated because of different reasons, GPS would degrade and it wouldn't work properly. So in this case, we need a fusion of sensor in order to improve the vehicle's location. This test is divided into separate phases. The first phase, it is supposed that we have GPS. The vehicle starts moving in order to reach to the goal location. And in RVs, you can see that localization and mapping are running through RTAP map. And in RVs also, we can see a graph base that are generated from the RTAP map. In the related terminal, we can see that the GPS location has been reached. In the second scenario, it is supposed that we do not have any GPS. So this is the case that the vehicle, the vehicle need to identify where and when to stop in order to identify the defect location. Here, the vehicle starts moving and use the trackside object as a reference point in order to specify the environments around the defect location and also improve the vehicle's location. Here we can see that by detecting the distance from the nearby objects, it starts publishing, and when it reaches to the defect location, the vehicle would stop.
Okay, right now I'm gonna repeat the demo we just did a moments ago, but this time I will share the screen sharing of the camera's view so we can see what does the robot sees. Right now the camera arm is going to the side of the track looking for railway defect, which will be represented by a QR code. Now it's moving slowly. Now, okay, it missed the first defect. Happens in real life. Hopefully, we're gonna find the second one. Okay, it finds the second one. You can see the screen. It shows in the red box. And it turns out it's type B defects. So you're gonna do some movement, show different pose of the camera, and take picture of the defects from different angle and save the GPS location. Job finished. Robot going back to initial.
I think it's better if you just explain the screen and then the robot arm movement. Fei Yang can explain so I can get the microphone on time. Okay, so please keep all your comments and questions you may have in the comment section. Just to conclude, we have seen how merging an array of sensors can allow this vehicle to position itself and navigate around the track. And then we have the robotic arm and the camera at the front of it, which mimics what we will do to detect defects on the railway using, for example, an ultrasonic test device. And the robot arm movement basically mimics what it will be a maintenance task carried out by the robot itself. So that concludes our demonstration. Please keep posting your comments and we will now answer all your questions. Thank you. How long was it?
12 minutes.
12 minutes totally.
Oh.
Live 12 minutes.
Okay, 12 minutes. Yeah. So I can make the conclusions a bit longer.
Yeah. Oh, the introduction.
就第一次 run 的时候，就是我先说，就是 the robot is stand by now， so we can start demonstration， 然后你再开始操作，
Okay, I will
就不然
end the
我就不知道就